Good day, viewers all over the world. You are welcome to Toilet online class. Today we want to look at the graphical method of solving simultaneous equation. Of course, this same question is the question that we solved using the other two methods, using elimination method and substitution method. So when we use it to solve elimination and substitution method, the value of x is given as 8. We got the value of x is given as 8 and y is given as minus 2. This is what we arrive at. S is given as 8 and y is given as minus 3. So when we use the other two methods, elimination and substitution method. Now we want to look at how we can solve this simultaneous equation using graphical method. Of course, the limitation under graphical method is that the use of graph will be required. So if you don't have graph book or graph board, we cannot solve this correctly. We can only estimate, like what we are going to do now. Now look at, we have to solve this simultaneous equation. This is the first simultaneous linear equation. This is the first one, and this is the second one. What you are going to do is that you are going to generate values for value of x range. X ranges from probably 0 to 2, or from minus whatever. You can decide to predict the range of value for x. You can say x ranges from 0 to 2. That is, I will say when I have this first equation, 2x plus 5y is equal to 1. I will generate value for x. Then I will look for value for y. Say y, and I will say this is x, and this is y. So what I'm going to do is that I can say my x ranges from maybe 0, 1, and 2. So I'll get value. I'll substitute value for x to get the value of y. Then I go to the second equation also, where I have 3x minus 2y is equal to 30. I'll do the same thing. I can generate value for x. Say x, maybe x, let's use the same value. X from 0, 1, and 2. Then when we substitute, we get the value for y. So in this first equation, when x is equal to 0, here, then y will be equal to 5y will be equal to 1. Then y will be equal to 0.2. Y will be equal to 0.2. When x is equal to 1, here, then y will be equal to 5y will be equal to minus 1. Then y will be equal to minus 0.2. Then when x is equal to 2, if we substitute for x equal to 2, we have 5y to be equal to minus 3. Then value of y will be minus 0.6. So these are the values that we are going to get there. So we come to the second equation. When x is equal to 0 here, then y will be equal to minus 15. When y will be equal to minus 15. When x is equal to 1, I'm going to have this minus 2y to be equal to 27. Then y will be equal to minus 13y. Then when x is equal to 2, I have 2 times 3, 6. I will have minus 2y equal to 30. Then y will be equal to minus 12. So we are going to use these two tables to plot the graph. Then we now locate the value of x and y from the graph. So let's see what we are going to get. So if you want to plot the graph, now you know this is not the graph board. So we are just going to estimate based on the value of x and y that we have. If you look at the table very well, the value of x ranges from 0 to 2. Then the value of y, most of the things that we have there, they are negative. So this is what we are going to get. We are going to get something of this nature. So this is what we are going to get. We say for x is just positive. We say this is 0. Here is, you can say here is 1 and here is 2. Then for the value of y, we have, we can just say this is 1. Or we say this is 5. Here is 5. Okay? If this place is 5, and this place can be equal to 1 can be somewhere here. Then here will be minus 5. Here will be minus 10. Of course, we are going to use scale. You can say 2 centimeters to represent 5 units, as we have it on the board. So now let's just estimate when for the first table, when x is equal to 0, x is 0 along y-axis, y is equal to 0.2. So if this is 1, the 0.2 will be somewhere here. This is not the actual value. When x is equal to 1, y is equal to minus 0.2. Let's say it's somewhere here. Then when x is equal to 2, y is equal to minus 0.6. The value will be very small. We're going to have something of this nature. The value will be very small. So of course, it's a linear graph. So it's going to be a straight line. So we're going to get something of that nature. So once you have this straight line, you can say this is a graph of 2x plus 5y is equal to 1. We go to the second one. When x is equal to 0, y is equal to minus 15. We are going to do that here. When x is equal to 1, y is equal to minus 13.5. 1 minus 13.5. You have something of this nature. When x is equal to 2, y is equal to minus 12. 2, you trace it to minus 12. Then you also join it. You join all the lines together. At the end of the day, this will be the graph of 3x minus 2y is equal to 30. So if you continue in that order, their meeting point will actually be the value of what you are looking for. So their meeting point will be somewhere around here. This will be the value of x. Here will be the value of y. The value of y will be here. Here will be the value of y. And here will be the value of x. So if you look at this very well, this somewhere around, you now write out the coordinate here. Then based on the knowledge of the theoretical solution that we have gotten the value of x to be 8 and y to be y to be minus 3. Of course, y is minus 3 because this is not the graph board. We cannot actually get the actual value. So here can be estimated as 8 based on the other method that we have done. Then y can be estimated as what? Minus 3. And that's what we have. The limitation, as I've said earlier on, about this method is that the use of graph book or graph board will be required. And in one of the classes, we are going to talk about graph generally. We look at some of these graphs. I will come up with the graph board. Then we are going to get this. But this is just an estimation. I just want us to have an idea on how we can actually plot simultaneous linear graph. Thank you.